Math 13 students, hello. This is the second half of the 6.1 material. We're going to look at the process here of finding a score given an area or a probability. This is the inverse problem compared to what we looked at previously in section 6.1. So we're going to start with an area. We're going to work backwards towards a score. All right, so let me go ahead and share my screen and we'll get going. All right, 6.1, the standard normal distribution using inverse norm. That's the tool we like here. Let's see. We have a bit of an outline. We're going to review the standard normal distribution. Probably the last time I touched bases there. Then I'll show you guys how to use the inverse norm function to calculate scores. We'll take a look at appropriate examples as we work our way through the topic. So, I'm going to remind people that the standard normal distribution is a bell-shaped normal curve, but it's a very particular one. The mean is 0 and the standard deviation is 1. And that's not just happenstance. That's really what makes it the standard. And if you think about it, it kind of makes a little bit of sense. So everything I look at in this section, I will be dealing with this z distribution. Now, a little bit about the inverse norm tool. We can calculate scores based on an area argument. So we provide the probability or the area, sometimes in terms of a percentage, and we work backwards towards a score. It's a little bit fussy. I need to provide probability to the left of whatever point I desire. I'll also need to know the mean and the standard deviation. Part of the issue is the way your calculator works with the inverse norm tool. I need to give an area summed from the left, not from the right, from the left. And it can be a little bit fussy. We're going to see some of the detail here in just a moment. First, we're going to need to ask it in the correct way. Syntax is very important here. The inverse norm tool takes area first, then it will need the mean, and then find the standard deviation. So I'll need to have you remember that we'll need to provide a probability here. And it's got to be stated in terms of area to the left of that desired value or point. And because of that, similar to the binomial CDF tool that we looked at in chapter 5, we will on occasion need the complementary argument to close the deal. Here's our first example. We want to find the z-score that separates the bottom 10% of scores from the rest. I'll use the inverse norm tool, but before I reach for that tool, I'm going to identify the region. I truly believe that drawing pictures for this material is very, very important. It really serves to focus your thoughts and actions. So I have the 10% of area on the left, and I'm looking for that particular point. By the way, how do I know that 10% is on the left? Bottom, low. Lesser numbers are on the left, greater numbers are on the right. Think in terms of Mr. Numberline, it'll be fine. So let me come over to my calculator. I have my stat wizard turned on today. I notice number 3 is the tool in question, inverse norm. Because I have my stat wizard turned on, I'll have a question for area. I'll hit enter. The mean, enter. Standard deviation, enter. Yeah, what I'm going to do is to plug those values in to the inverse norm tool, very similar to the binomial CDF tool we've used. I'll hit enter, and I'll get a value. There's no hard and fast rounding rule, but I do like 3 decimal places for this kind of number. So 1, 2, 3. The 5 tells me the 1 needs to be a 2. So back over here. That point in question that separates the bottom 10% of z-scores from the top 90% is a negative 1.282. Now, here's your second example. We want to find the z-score that separates the top 15% of scores from the rest. The process is the same. The picture here is even more important, perhaps, than it was in the first example. You'll notice that the top 15 on the far right of the normal distribution here. My calculator can't deal with that kind of an area. It needs to take the area up to that point. So I've got to frame this in terms of the complementary argument. The area, or 0.85, that's 85%. And by the way, most of you, I think, can get there pretty quickly without overthinking this problem by realizing that the total amount of area has to add up to 100%. So we've got our values there. I'll come over to my calculator, pick up the inverse norm. I could plug in 0.85 or 1 minus 0.15. So I can do it exactly like that. 0 and a 1. And hit it. So I get a 1.036 and change, 3 decimal places, 0.036. So the score that separates the top 15% was 1.036. Now, a third and final example. We'll run into this an awful lot as we go through the semester. Sometimes we have to work through it in this fashion. Sometimes we have other tools to deal with this kind of situation. But set of scores from the rest. So not just one score I need here, it's 2. Now, I could do the problem twice. In fact, I probably will. I'm going to show you how we can do it with just a single set of keystrokes. And it riffs off the notion of the symmetry of our normal distribution. So if I come over to my calculator, I'll plug in 0.05 for that 5% over there on the 0 and 1 go in goes the paste, and I get a negative 1.645. If I round that to 3 decimal places, the 8 makes the 4 into a 5. Now, symmetry tells me that if it's negative 1.645 over here, it'll be essentially the same value, but positive on the other side of the 0. It's the symmetry of the graph. It's the same on both sides, kind of like your ears, more or less the same height on both sides of your head. So I really have my answer, but let's see what we got here. And we get a 1.645 on the right, a negative 1.645 on the left. Now, suppose I don't trust Mr. Symmetry here. Well, that's not a problem. One minus 0.05 or 0.95. Ooh. %5 here, 95% down there, and there's the positive 1.645. So you can use symmetry. You can do it twice if button pushing is kind of your thing. Either way, the symmetry tells us that they differ essentially by a sign here. So a little bit of a summary. We've just used the inverse normal tool to find scores that follow a normal distribution. It's going to work with any normal distribution. Here it was the z distribution. It's important to draw the region first. You really need that to focus your thoughts. So to calculate the scores, you'll also need to remember to enter in that area as measured from the left. You're going to use the complementary argument if necessary. You saw an example using that. Now, you'll also need to remember the normal CDF is the tool that finds probabilities, while the inverse normal finds scores. It's important to keep these straight. You don't want to confuse them. Normal CDF, probability to scores. Inverse normal, scores to probabilities. Don't confuse those two. They'll wreak havoc with your button pushing. So we reviewed the standard normal distribution. We used the inverse norm function to calculate scores, and we've looked at several appropriate examples. So I'd like you to take a look at those homework problems. Again, the practice with the button pushing cannot be overstated. That's the end of what I've got to share right now. I'll be back with more fun stuff later. Let me stop the sharing while I'm ahead. Let me wave goodbye and ask that you go away, do some work, and come back with some questions.